So recording has stopped. Okay, have you started the recording? Thank you, Dr. Sukalyan. Yes, we missed it yesterday also. The initial part, we forgot to press that button record, and that was not recorded. But again, I'll record it and we'll send it to you. But thank you for a reminder. So Sariful is asking, explain the pre-testing. So pre-testing is all that process which we are doing now. Pilot testing was we did yesterday. Pre-testing is that exploratory factor analysis, the reliability and the confirmatory factor analysis. So that is the pre-testing of the scale. And once we have finalized the scale, then we will administer that at scale. So in the pilot testing, we got the version 1 of the questionnaire, like you have removed some item, you have deleted, like we did yesterday regarding that STARS questionnaire. And now based on that 35 questions or whatever was the final tool which you thought that this item should be retained, this item should be removed, on the basis of that, you will do now the exploratory factor analysis. So on the same tool which you edited yesterday, you will do the exploratory factor analysis today in the breakout room. Okay, I'll show you on one data and then you will do it and then you will understand and then you will compare also, like the construct or the domain or the dimension which the scale has mentioned and what you people have clubbed it. Was it the same or a different one? So there can be, because we will share you many papers of GHQ 12 and we have seen they have many corner of the world, they have reported that ideally the initial dimension of the GHQ was 1, it was single dimension. But they have found out that in their country, somebody has did 3 factorization, 3 factor, 2 dimension, 4 dimension. So based on their subjects or respondents, they said that their respondents are categorizing it as a 2 dimension or maybe 3 dimension. We will share that paper with you today and maybe you can do that as a homework also. The end of the day assignment, not in the form of assignment, just in the form of a reading. So I think it's 4 now, so it's high time we should start with the exploratory factor analysis. So now we discussed regarding this mental mapping and response yesterday also. So let's see this, whenever the child is born, the brain is very new and no information is registered in the brain. So that overall processing of the information, it is done when the child gets any exposure. So like maybe a child in this case, the child is exposed to, you can see there is an egg, maybe somebody is angry or sad, he understands it as a sad. When he sees a car, he says it's a car, maybe some vegetable, maybe some fish. When he sees some transport, this thing like maybe car and cycle and so on. So he registered these things and now he wants to make it a little bit objective. So the child registered all these information in the brain. Initially, he is not aware how to club it, but simultaneously the child learns how to group this information as per social norm. Like if you ask a child, he will group the egg and fish together. Maybe then he may group this orange and apple together. And then maybe he will group the cycle and car together and these two as together. Maybe in qualitative also we have learned regarding this grouping. And then overall it may group it as a e-tables and like that. So but he will never group this car to this e-table group or maybe this mood like angry and happy here. So again, so this is like processing, how our brain processes these information. So making mental mapping and grouping these sort of objective item, it is an easy task because you are visualizing it. Our mental map is prepared and since beginning, we have been registering information about these objective things. But when something we talk about like a construct, we talk about emotion, we talk about love, we talk about happiness, such things, because consciously we are not registering such a thing, but again that is there in our subconscious mind. Maybe it may anytime it may jump into the conscious mind. So but this is difficult for a subjective task. That's why we say that if you do it subjectively, you are not going to be correct. So that's why there are mathematical technique, which understands this and which categorizes these items into a similar looking construct or similarly coded construct. And this is based on the observation, like what participants have marked. Because in your group setup or in your subjects, whatever they are considering, whatever they have perceived, because yesterday we talked about that social norms are different for different society, perceptions are different for different society. So that's why in your subject, how they are perceiving that construct, or how that construct is affecting those items which they are filling, because by the help of those items you are trying to measure a particular construct. So it is like, you can see this is just one analogy. So there are different color balls here. You can see there is a brown color ball, there is a peach color, blue, shades of blue, red and black. And like if you want to make a grouping of this, so you can again group all blue looking together in at one place, maybe black as a different, and maybe all shades of like these peach, orange and red together at one place. So this is the grouping. So you can take each ball as an individual item and maybe each group as a factor. These are grouped together. So it is easy to do this activity based on color, because it is visible, tangible. We talked about the tangible and intangible, but for psychometric scale or the psychological visibility, this is not a very easy task. So in case of scale validation, this net is called the factor analysis, because through this net, when the items they pass through this net, you get a dimension reduction, or you get a decreased number of dimension, and it is easy for you to analyze. So that's the advantage, or that's the objective of a factor analysis. So now what is a factor analysis? So basically in factor analysis, what do? We clarify, or we say that there is a relationship of the scale item to the latent variable, because that's our primary aim. Whatever item we have selected, whether that is measuring that particular latent variable or not. And we discussed this a lot yesterday. Again, we discussed regarding the reflective model and regarding the causal formative model. In the reflective model, we discussed that reflective model is that item is a reflection of that latent variable or the construct. So that particular item which you have selected, that may be affected by the more than one latent variable. So you need to say or check whether there is a single latent variable which is responsible for the variation, or there are multiple latent variables which is responsible for the variation in the set of the item. And that's how you have to select the item wordings that corresponds with the intended level of the variable specificity. So the choosing that item wording is very important and very intensive task. It is not very easy. So basically this factor analysis is used to assess whether that selection process, the items which you have selected, whether that process is succeeded or not. And it is based on the classical measurement theory. There's another theory which is known as the item response theory, or IRT, but we are not going to discuss that item response theory. This factor analysis is based on the classical measurement theory, which states that number of items a particular scale has, it has got those many. It says that it is a unidimensional. That means all the items are measuring a same single construct. So it says again that this is the latent, if the latent variable is affect is like mood, maybe if it is that, then if you have got 25 items, then there will be the 25 factors. So classical measurement theory that says that each item is measuring a different a different construct, and each item, those many factors are there in your model. Like there is a latent variable affect, so it may tell you affect has got many shades, like depression, that is also affect, euphoria, that is also affect, hostility, that is also affect, and anxiety, that is also an affect. So a latent variable affect has got various forms. So your item is measuring a particular special dimension, like in this case, or it is affecting a overall. Again, you can classify this as a negative effect or as a positive effect. Again, this again can be classified as sad or happy. So affect has got many dimensions. You can see here. You can classify it as sad or happy. You can classify it as a tense or calm. So any latent variable which you have, it has got more than one, it may have more than one dimension. It is not necessary. And this factor analysis helps you to understand that whether it is a one-dimensional or whether it is a multi-dimensional. And that's how there is a need to do this factor analysis. So the question is there in front of us, that does a set of item asking about several affective states have only one latent variable or many latent variable underlying it? And that's how the purpose of factor analysis is, to determine how many latent variable underlie a set of items, and it condenses the information because it reduces the number of factors. Because classical measurement theory says that if there are 25 items, there are 25 factors. But ultimately, when you do the factor analysis, it condenses the information and it defines the meaning of factors also. Although the factor analysis will not tell you what to give the meaning of that particular construct, because it will club those questions and items together. Now it is up to you or the expert person to decide those clubbed item what you will name for, and then you will identify the items, in this case, which they are performing better or they are performing worse. This is a very one powerful tool which tells you that which items are performing better or which items are performing worse. So now we have discussed regarding the reliability analysis, and we have seen that we calculate the Cronbach alpha. But there is a limitation of Cronbach alpha. The first limitation is a high alpha value. It does not guarantee that all items reflect the influence of a single latent variable. It is a limitation of alpha. The another limitation is, as you increase the number of items, the alpha value increases. So for a 25 item scale, even if only 0.14 inter-item correlation is there, it will yield an alpha of 0.8. So again, it is a limitation. And alpha is appropriate only for a unidimensional item set. Although we have got a McDonald omega, which which tests this without a concept of dimensionality, but again, it may mislead many a times. That's why only doing the validity studies or only using the scale based on alpha should not be done. Now, what this factor analysis, this is an empirical method, means it is based on the observation and it is based on the data, and you do an analysis, and it's a technique by which you decide how many constructs are there in your set of item, whether it is a single construct or whether it is a more than one construct, how many latent variable are there, how many factors are there actually. So the purpose of factor analysis is, you have to decide how many latent variables are there in a set of item. You condense the information and you define the meaning of those factors, because those factors which are clubbed together, you define what will be the meaning or how you are going to name that particular construct. And then again, we have said this before also, you identify the items that are performing better or that are performing worse. So now how this works. So we have discussed yesterday that in the reflective model, that a particular construct is there and you have got an item, and the variance in a particular item, it is due to the underlying construct. So you start the considering all items under one construct, and then you see that how much of the variation in the item is explained by that latent factor. Then how much of the variation means, we will see this with an example also. So like if there is a factor and the variation is 30%, which is explained by the construct. So rest 70%, is it explained by some other factor? So if yes, Again, how much? Maybe let's say 40%. So again, the leftover is 30%. So the how much variation in the item is explained by the third latent factor. So this process, the background in the analysis, the statistical analysis, this process goes on happening till a very small amount of variation is left at the end. So that's how the number of factors, it takes out till you have got very less amount of variation left. So that's the basis of how many factors a particular software extract. So in this case, like you have started with a factor, that is, I am not naming it like maybe any factor 1, and there are A, B, C, D, A to I, these are the items. So there some amount of variation will be explained by this factor, and the amount of variation, if that is left, which is not explained by this factor, that will be explained by another factor. Again, you can see the direction of arrow, and in reflective, you know that this factor, this item is a reflection of this construct. So the direction of arrow is in this direction. So this is a 2-factor model. Similarly, you may have a 3-factor or 4-factor model. So in the course of scale development, we often want to know about the few, which is the most influential source of variation underlying in a set of items. And not every possible source we can find out. So we try to extract those many factors which are most influential, because 100% variation you cannot explain. It is very difficult to explain. So the factor analysis, basically there are 2 types of factor analysis: exploratory factor analysis and confirmatory factor analysis. Again, in exploratory factor analysis, there is another term which is known as the principal component analysis. Now, there are many authors who consider this exploratory factor analysis and principal component analysis in the same family, because if you see the steps, they are almost the same. There are some differences, but we are not going to discuss those differences. If nothing is known about the factor, and if you have devised the scale for the first time, then you may take a call to do this exploratory factor analysis. If something is known about the factor or something is known about the construct and the dimensions, then you can decide to do a principal component analysis. Although if you see the output and options, they are same. Even the JAMOV, it yields the same. There are some underlying assumptions which makes it different, but which we are not going into the minute detail of those underlying or the background thing which is working with this principal component analysis and the exploratory factor analysis. So first we'll discuss the exploratory factor analysis. So there are some underlying assumptions of this exploratory factor analysis or the principal component analysis, that there should be multiple variables and they should be measured on the continuous scale, because we will see that all the assumptions and all the calculation that is done on the basis of the correlation. So correlation generally we apply on the continuous scale, and this is one assumption of correlation, that there should be linear relationship with the variable. Ideally, you can test that with a scatter plot, but again, even if you don't do, if you have got a 7-point scale, and then if it is a continuous scale and the number of samples are large, then you can go ahead with the doing this exploratory factor analysis. Again, there should not be significant number of outliers. And regarding the sample size, we have discussed yesterday that at least there should be 300 sample. And again, with the items, if there are 25 items, so you can decide a number of sample per item. So if there are 25 samples, and if you want to do a EFA, so for EFA, we say that 10 items, 10 samples should be there per item. So it should be like 250. Similarly, if you are doing CFA, you can take 5 sample per item. So that is the rough guideline for the sample size. And then there is an assumption of sphericity and sample adequacy. So we'll see what is this sphericity and what is this sample adequacy. Now there is a concept of multicollinearity. So before I explain this sphericity and sample adequacy, what do you understand by multicollinearity? So multicollinearity is the similar object or similar subjective domain correlating with each other. So like in this picture, you can see that all these are the kitchen utensils. So this will be like a multicollinear. Again, these are all vegetables. So this will be again multicollinear. This will be again, that means linearity, that means the relationship or the correlation value will be very high. Again, this will be a multicollinear. So you can figure out that these some underlying construct that these items are highly correlated with each other. So in the same analog, when you use many items to measure a construct, then you can appreciate that all these items must be correlated to a certain degree with each other. And the existence of such correlation between all the items of a scale is collectively called as the multicollinearity. So the null hypothesis says in the Bartlett's test of sphericity, so we are discussing sphericity now. So the null hypothesis assumes that there is no correlation between these items. So for Bartlett's test of sphericity, test this assumption. So for scale development, the desired p-value should be less than 0.05 because you have to reject the null hypothesis. And the null hypothesis says that there is no correlation. So if there is a correlation, then only you can perform the exploratory factor analysis. So this sphericity, again, it is tested using the Bartlett's test for sphericity. So it checks that the variables are related to each other or not. The null hypothesis states that there is no multicollinearity or there is no correlation. Therefore, if the p-value is less than 0.05, it satisfies the assumption and it measures the existence of a significant correlation. And if the value is less than 0.05, you can say that this data is suitable for the exploratory factor analysis. Now, the second concept is the sample adequacy. This sample adequacy is measured, which is known as the Kaiser-Meyer-Olkin or the KMO measure. So it is the Kaiser-Meyer-Olkin or the KMO measure, which measures the proportion of variance among the observed variable and which is due to the common variance. And if the KMO value is less than 0.5, then this data is not suitable for the exploratory factor analysis. So the KMO value should be at least 0.6. Otherwise, you have to discard the data and you cannot do the exploratory factor analysis. This KMO tells you regarding the sampling adequacy. So there are two ways to assess this sampling adequacy. One way is like we have discussed, there should be 10 items or there should be 5 sample per item. And this again, this is one objective way of assessing the sample adequacy. The sample which you have taken to calculate the exploratory factor analysis, whether it is suitable for that or not, that many samples are there or not. So this KMO measure, this value of KMO should be at least 0.6. Again, we define the meaning regarding that if it is more than 9, it is a marvelous data. If it is 0.8, between 0.8 to 0.9, we call it as a, oh yeah, by mistake, it is 9, it is 0.9. I'm sorry, meritorious, simply middling. If it is 0.6 to 0.7, we call it mediocre. Less than 5 is not acceptable at all. Now, there is something known as the eigenvalue. So this term you will see in the JAMOVI. So this eigenvalue is the sum of variance. So now don't go into the statistical definition of all these, too much of definition. So this eigenvalue is the sum of variances of the factor's value. So if a factor has a low eigenvalue, then it adds very little to the explanation of variances in the variable and it may be disregarded. And that we will see. So if in the factor analysis, you have to decide how many factors you have to take. I'm just telling you the theory now. We will see it practically also. So if there are many criteria, there is some subjective criteria and there are few objective criteria. So if the eigenvalue is greater than 1, that means it is adding to the explanation of the construct. So you can take those factors where the eigenvalue is more than 1. You can do there is something known as the scree plot. Scree plot, we will see that it is a plot which is based on the eigenvalue. This is a subjective way because that's a plot like we have seen it in the QQ plot. Remember when we check the normality in the SPSS, we have got a QQ plot and we have got other objective way of assessing the criteria also. Similarly, the scree plot is a subjective way. And then there is a parallel analysis technique. So this parallel analysis technique, this is considered superior of all these three. And in this parallel analysis, what it does, this software, in the background, it calculates the eigenvalue of a random data. So it yields many sets and it calculates the eigenvalue based on that data, and then it compares the eigenvalue of your data with that random data, and that's the parallel analysis technique. So this is a scree plot. You can see this is the eigenvalue. So we take the eigenvalue cutoff of 1. So in this case, we define as inflection point or the elbow point. So from where it has started decreasing sharply, we call it as an inflection point. Many times this is clear, many times this is not very clear. That's why we call it as a subjective criteria. Now there's another concept which is known as the uniqueness and communality. Now, what is this uniqueness? So we remember we call that the variance. So first I will define this communality. Please forgive me, in communality by mistake I have written community. It is the communality. So communality is the variance which is explained in that particular item by the underlying latent variable. And 1 minus communality is uniqueness, or the other way down. So what is uniqueness? Uniqueness is the proportion of variance that is not explained by the underlying factor. So that's why we want our item to be of high communality and low uniqueness. Because if it is high communality, that means largely the variance or the variation in that item is explained by the underlying construct. So again, few more slides on communality versus uniqueness. So communality is the amount of variance. Yes, I am repeating, Shivaji. There are 3 slides. So communality is the amount of variance. And again, I'll repeat once again. I will repeat it many times in the output also when I will show you the gem movie. So communality is the amount of variance of an item which is explained by the concerned factor or the concerned construct. And uniqueness is the remaining amount of experience of a variance in an item which is unexplained by the concerned factor. Okay. So like if a communality of an item is 0.72, then we can say that 72% of the variance in this item is due to the particular factor, and rest 28% variance is unique to the item. So the shared part or the common variance is 0.72. That's why we call it as a, ideally it should be commonality, but we call it as a communality. So shared variance will be communality and unique variance will be the uniqueness. So unique variance, which is not explained by the factor, that is known as the uniqueness. So what do we want? We want this shared variance to be high. So we want this communality to be high and uniqueness to be low. Yes, so uniqueness is a kind of error. Yes, remember this, I have shown you yesterday's slide. We have shown that there was an error term associated with all the item. In case of a reflective model, that error is associated with the item. In case of a formative causal model, that error is associated with the construct. So this error, E1, E2, E3 is the error or the uniqueness, which is not explained by the factor. So in the SPSS, you get the communality as an output, but in JAMOV, it reports uniqueness. So that's the difference between the output between a SPSS and JAMOV. That's why I'm explaining both the things. But in JAMOV, you will not see communality. But in many other software, like SPSS, AMOS, and maybe the Strata, SAS, those of you who do it, they report, although I have not done it, but I have seen the output that it reports the communality, not the uniqueness. Is it clear now, the communality versus uniqueness? Again, I will repeat it. Okay. So this factor analysis it tells whether the item selection process, whether it was successful or not, and that we have discussed, that is one of the objective. And this is one question I think all of you know. Factor analysis is done for which type of construct? Reflective, formative, or both? So what will be your answer? A. So Sumit is asking, would it be better if we take one example of what? This uniqueness and communality. That we'll see in the output. I'm just showing you. I'll give you a lot of example. Don't worry, because otherwise we will be late. I will show you. So let's remember some cutoff for this factor analysis. So the KMO value, if it is less than 0.5, we discard it. But ideally, it should have more than 0.8. The total variance explained in factor analysis should be more than 60%. Again, we'll come to all these figures, don't worry. The communality, ideally, it should be more than 0.5. What we call it as a high loading, but again, at least if it is 0.4, more than 0.4, it should be there. And then there is something known as the rotated factor loading. That should be more than 0.45. We will understand this concept of rotation also. Just please hold on for some time. And then the value of Cronbach alpha should be more than 0.8. So remember all these values just to analyze and interpret the result. So now let's understand the concept of factor rotation. What is this factor rotation? This is very important because with this rotation technique, it's a 3D concept where the it traces out minimum distance between the factor and the maximum looking items in one factor. So imagine yourself in a room where there are bulbs of multiple color hanging from the ceiling. It's by mistake, it is written hanging from the floor. Read it as a hanging from the ceiling, and you are moving. So you measure the distance of every bulb from you. So like you are standing here, and remember, just imagine it as a 3D. So you measure the distance of every bulb from you. You sum all these values. So let this value will be x1 for position P1 in this room. Now you have moved a little ahead. You have changed your position to P2. Again, you measure the distance from all the bulb with your point and sum all that distance, and that will be x2. Again, you have moved and you have changed your position and you have measured again distance, and sum of that will be x3. So are you clear what are we doing? Imagine there is a room, there are bulbs which are hanging from the ceiling. You are changing your position and you are moving the distance from you and the bulb, and you are taking the sum of all distances. So can you appreciate that there will be a position in the three-dimensional room space where the sum of all distances will be the least? That means whatever balls are hanging, the sum of all distances will be the least in respect to your position. So that particular thing is known as the rotation. So what will happen if we restrict the movement in room space? If we allow the movement only in perpendicular direction, like if I say that you can only move along the walls, along the perpendicular direction, will this restriction increase the chance of getting this point or restrict the chance? So answer will be like, if you restrict the movement, definitely the chance will be less, because then it will have the option of only those 2 points what we see, right? So that's why if there is no limitation in movement in the room, there will be least distance. But if you restrict the movement in the room, then definitely there will be resistance, or there will be restriction in getting this minimum distance from that particular person. So now you finally got one point, and from this point, you try to look at all bulb and then try to make some pattern in distribution of these bulbs. So like you can again club these together, like maybe red. So all bluish shade bulb in one group, or purple shade bulb in one group, all reddish shade bulb in one group. So you are standing at a place where the sum of the distance is minimum, and then you are clubbing these together. So this concept is known as the rotation. So now what is rotation? Rotation is it helps you to visualize the factor, to see the factor more clearly, and to club them together from where the distance is least. Like you can remember this, and you can imagine the analogy of in linear regression, we draw a line of that best fit. So what is that best fit line? Where the distance of all the residuals are minimum from that line. So that we define as a best fit. So that was similarly this rotation you can imagine of the same concept, but sometimes we may not find any pattern at all. Whatever position you shift, you may not find any position or any clubbing of those factors. In that case, it will be a unidimensional scale, that even if you change the rotation, you are not able to find any factor. So that will be a unidimensional scale. So now let's understand this rotation of factor to measure the construct of interest. So again, replace the room space with the psychological space of the study population, replace the individual with the construct, and replace the bulbs with item you asked in the measure of construct. So can you imagine now this rotation? There's a psychological space, which is like a room, the individual, the person, which is the construct, and the bulb hanging from the ceiling, those were the item. So in the psychological space, distance between construct item, factor item, item, and factor, that is measured as correlation coefficient. So we discussed that all these analysis is based on the correlation coefficient. Again, this is one example, like this is one observation of rods. This is without rotation. So if you do some rotation, it helps you to visualize that these are in an ordinarily, in a some fashion. So you can see that they are arranged 90 degrees with each other, and you can now visualize the pattern very clearly. So this was without rotation, and this was with rotation. So this helps you, rotation helps you to orderly arrange the item from that perspective, which reveals that it is order, it is in order. So am I making sense to all of you up till now? Then I'll move ahead. Or do you want me to repeat anything? Please type yes, no, or anything, so that, because I can't see your faces. So Shivaji is saying example will help. So example, rotation, actually that's a mathematical concept. So again, I have asked you, like example, you can imagine this bulb. You can see that like the construct which you have measured yesterday, that was the statistical anxiety. So now if you will do a factor analysis of statistical anxiety data, I don't know how many factors you will get, but though the factors you will get, that means that, and the type of rotation which we'll use, because rotation method you have not seen in the JAMOV. So that rotation, generally we use the oblique rotation, which we call it as oblimin. So that oblique rotation will help you to visualize that these constructs are there in the mind of the people as a together, as a togetherness, right? That is the rotation concept. Okay. So I think because it's a pure imaginative. See, because I'm not from my engineering, maybe we can give it to some virtual creator, and then they may create it so that you can visualize it. But at the max, we could do this so that you can have some sense of how this rotation works. But ultimately, every where you will see that they say that this rotation helps you in better visualization of the factor, and it tells you that the minimum distance of those factor from that particular construct. And then this is the item. So this is the question which we are going to use for our purpose. And now how to report that I'll show you later. So there are some problem with this. There are some shortcoming of this EFA. It is a subjective technique. Names of the factor needs to be decided by the researcher, and there are many rotation methods. So this was the theoretical concept. Yes, there are many ebook, Bhavna. We will share you. I think we have you. Okay, we'll share you reference. There is a Sage book, that is the 4th edition. Everything will be there in the book. Sorry, in the website. You can definitely refer. So now I'll show you the data, how to do that. So we have discussed the theoretical concept. So this was the data. So this we have taken the data because in our practical experience, we have not conducted till now any research. So that's why we are using the data which is there in the Jamovi bank. So in Jamovi, they have also given a lot of data on which we can practice. So we have taken that data, and we have taken that personality example. So personality traits, there are 5 personality traits, and let me show you if I have that slide or not. Yes. So you can see here, where is that question? It was just there, no? That personality. Just a sec, give me 2 minutes. Okay, this slide. So this was a questionnaire which was, there were 50 items, and this is a big 5 personality test. So this big 5 personality test, it measures the 5 personality factors that psychologists have determined they are core to our personality makeup. And these 5 factors are, the first is openness. Openness means how open a person is to new ideas and experiences. The second is consciousness, which is how goal directed or persistent and organized a person is. The third is extraversion. What is extraversion? How much a person is energized by outside world. The fourth is agreeableness. How much a person puts others' interests and needs ahead of their own. And the last is neuroticism. How sensitive a person is to stress and negative emotional triggers. So each of these factors, or the 5 personality, has 10 items. So there are 50 items in total. So 10 for openness, 10 for consciousness, 10 for extraversion, 10 for agreeableness, and 10 for neuroticism. So we have taken the data from that bank, and we will show you how to do the exploratory factor analysis on that data. So this is the Jamovi. So now you know how to import the file. So click this, go to open, and then you can browse the respective file in the Jamovi. Again, you can see some of our videos on the Jamovi, which we conducted 2 workshops, I think 3 workshops on Jamovi. And then these are the variables. So how to do that? So before I start doing any analysis, the first is to move all the variable. So in exploratory factor analysis, we don't know like which item will load in what factor. So that's why we send all these items together in one box. So I have selected first item, then I have pressed the shift button, and then I have scrolled it down. I have gone till the last, that is the openness. And then I have shifted this here. So before I check anything, now focus on this. Don't focus on the output. So first you see this, there is something known as the assumption check. So before you start your analysis, you have to check the assumption. But whether your data is suitable for EFA or PCA or not. PCA again we'll discuss, but right now I'm focusing on EFA. So whether your data is suitable for exploratory factor analysis or not. And we discussed about the Bartlett's test of sphericity and KMO measure of sample adequacy. So this Bartlett's test of sphericity says that there is no correlation between these items, and we have to reject this null hypothesis. That's why the value should be less than 0.05. So that, and the second one was a KMO measure of sample adequacy. It should be at least more than 0.7. If it is 0.8, then it is very good. So these are the 2 assumptions. So what I'll do first, I'll check this, whether I have to see whether my data can be analyzed or not using whether I can do the factor analysis on this data or not. So I'll go down and I'll see this assumption check. So first focus on this. So what is the p-value? So p-value of this Bartlett's test of sphericity is 0.001. That says that it satisfies the assumption, this Bartlett's test of sphericity assumption is met. So now this assumption is okay. Now coming to the measure of sample adequacy. So the sample adequacy, this gives you the overall MSA. MSA, the full form is the measure of sample adequacy. So there's an overall value. So overall value is 0.885. And if you see all other values, it gives you item wise also. So item wise also you will see that all the values are more than 0.6 or more than 0.7. So in this case, what we have read, that if it is less than 0.5, you have to discard. You can't do the exploratory factor analysis. So if you scroll down, you will see that all the KMO measure is saying that it is more than 0.8 rather. Some values are 0.7, but again, everything is more than 0.5. So you can say that the assumption is met. So now you can start with the method of extraction and method of rotation. So now in this, now focus on this part. So this is method which we have discussed. So there is a method of extraction and there is a method of rotation. So in the method of extraction, if you just see the drop down menu, then you see that there are 3 options: minimum residuals, maximum likelihood, and principal axis. So the most common method of extraction of these factors is the principal axis, and in the rotation, the most common is the oblique, what we have done. In the rotation also, see there are many methods of rotation. Like there are many methods of regression. Remember, when we use the regression, there is a backward regression, there is a forward, there is a we can say there's a standard, which we call it as a enter method. So all these were the methods of regression. Similarly, there are various options for rotation. And remember that we discussed that oblique rotation is the best. So we click this oblique rotation here in the exploratory factor analysis. So what we have to click? Principal axis and the rotation. these two methods of extraction. Extraction method is the principal axis and rotation is the oblique. Now, we have discussed the criteria of how many factors to decide. So this is one area where you can decide. And we have discussed that oblique means the person is free to move in any direction in the room, in that construct. So remember that mental space as a room and that rotation method, one of the method of moving that construct into that room as a oblique rotation, right? So this is factor, and you can see there are three options. You can choose the options which you like. So you can either click on the eigenvalue, either you can click on the parallel analysis, or this fixed number we don't decide beforehand, but first we go either with the parallel analysis and or in the eigenvalue. What was a parallel analysis? People say that this is better. Why? Because it creates in the background a random sample of data, and from that it measures the value of eigenvalue and it compares with your observed data. But again, even if you click this based on eigenvalue, that is fair enough. So right now I am going with the very basic one. So I have clicked this based on the eigenvalue. And we know that eigenvalue, if it is more than 1, then that means that that factor, we will retain that factor. Now, in this case, there is something known as the factor loading. So now what is this factor loading? So factor loading is again related to the correlation. So if an item and the other factor, if the correlation is less than 0.3, then we don't want that item to be loaded on that particular factor. That is one essential part. And that's why we say that you hide the loading which is below 0.3. That means don't consider those items in that factor which is showing a correlation of less than 0.3. So this is regarding the factor loading. Ideally, we say a strong factor loading means the value should be more than 0.5. So that is known as the loading. That is the concept of loading. Now there is another box which you will see here, which is the output, additional output. So remember we talked about scree plot. So you can click the scree plot. This is again, this initial eigenvalues, it will give you the eigenvalue for all the factors. And then there is a model fit measures. Model fit measure we will discuss maybe today, I will try, or maybe tomorrow. And then there is a factor correlation. Factor correlation means number of factors which is that it has identified. And then there is a factor summary. So I will click this factor summary, factor loading, initial eigenvalue, and the scree plot. Now see this output very clearly. I'll go up now. So we discussed something known as the factor loading. So can you see this factor loading? So now I have asked that you don't load those factors which are less than 0.3. So that's why you will never see a value less than 0.3 in this column. You can see some empty column here, empty values. What are these? Can anyone guess? Can anyone guess? Dr. Shivaji, maybe you can try. Those items are not in the factor, not defined. Yes, so I think both Shivaji and Riya is right. The loading, you have given this command of hide loading below 0.3. Like if I remove this command, then you will see that it appears. Maybe it doesn't take, but in SPSS you will see that this appears, right? 0.3. You can change this also. So it has these values, yes. Less than 3 correlation values, that is not appearing here. So that's how we define this, that why these are the empty spaces. Now ignore these values, the negative ones, because that may be because of the reverse coding of the item or the questions. We have not gone, but we have discussed that if you are getting a negative correlation, that means that questions are reverse coded. So, but that doesn't affect. Then you have seen Now there is something known as the simple structure. So before I explain simple structure, can you see something here as uniqueness? Let me show you. Please focus on this. So now you can see on factor 1, this E1 is getting loaded. E1 was the first question, first item of this construct which we have defined. So this uniqueness was 0.506. So now what do you understand by this 506? Yes, anyone? Can you explain this 506? We discussed the uniqueness. Because I said that this JAMOVI doesn't give you the value of communality. It gives you the value of uniqueness. So can anyone unmute herself or himself and explain why, what does this 0.506 conveys you?
50% of the variance is not explained by the factors.
Yes, very right, very right. Absolutely perfect. So that's the uniqueness, and the other will be the communality. So in this case, you can see the comment and you can paste this table as such, and you can comment on the uniqueness or the communality depend. But since JAMOVI gives you the output in the form of uniqueness, so that's how you should be explaining the results. So that was regarding the uniqueness. Now coming to the simple structure. What do you understand by simple structure? Simple structure is we will take only those factors where the item which got loaded, it is more than 3. At least 3 items, 3 or more than 3. So this you can see it has extracted how many factors? It has extracted 5 factors. You can see. So out of 50 items, it has extracted 5 factors. It has clubbed all these E1 to E10 in one construct, N1 to N10 in one. Again, you can see here N4, it is not, I think N4 is not getting loaded here in any of the item. And then if you come down, you can see there this A1 again 0.453, 0.477, these are the values loading. And you can see this A10. Now, can you see this A10 is getting loaded on factor 1 and factor 3, both. So simple structure is that the loading, where it does the loading, this should be more than, at least it should be a very strong loading. But you have seen that it is not a very strong loading. Strong loading means at least on one factor it is more than 0.5. But in both cases it is less than 0.5. So that means that loading is less. And again there is a cross loading, means it is getting loaded on 1 and 3 both. Again, so you may, you have to report this. Again, if you come here down, you will see that this C4 is getting loaded on the factor 2 and factor 4 also. But again, here you can see that there is a one strong loading, 0.53. So you take a decision to keep this item in factor 4, not in factor 2, because this value is less. So if a item does the cross loading, what do you mean by cross loading? That means that item is getting loaded on more than one factor. Then you consider that item in that factor which has got strong loading. In this case, it is getting loaded strongly on this. That's why you will consider this item in factor 4. Similarly, now if you come down, you can see these many items again clubbed together. So this EFA also helps you in deciding the deletion of items again before you go for the CFA. CFA is the confirmatory factor analysis. So again, now you will remove this item. In this case, like if you can take a decision of that 0.3, there was one question which was not getting strong, this A10, you can take a decision of removing this item, this 0.3, because it is getting cross-loaded and it is not getting a very strong loading also. So you may remove this and again rerun the EFA also and see what is happening. Okay, so this is one way. So this is the interpretation. So now it has taken out 5 factor, and how this has decided to take 5 factor. So we have given this a number of factor based on eigenvalue. So if you come down, it will give you the eigenvalue. So I'll come to the eigenvalue. If you see the factor statistics, it tells you about the loading. So the loading of factor 1 is 5 point, it is a high loading, 1, 2, 3, 4, 5, and it shows you the variance. So we remember we have discussed that the number of factors which it has extracted, that should explain at least 60% of the variance. But this is not very good, because these 5 factors are explaining only for 40.8% of the variance. So of this construct. So this construct is this one, 40.8%. Okay. So this should be at least 60%. But in this case, it is only 40%. But again I said that it depends on the data, but you have to report it. Now, if you focus on this inter-factor correlation, we discussed about the discriminant validity and convergent validity. So you can do that here with this also. Content validity you cannot, but convergent validity you can decide from this table. This table gives you the inter-factor correlation. So if the amount of correlation in any of this inter-factor is less than 0.3, that means there is a discriminant validity. And you can see all the values are less than 0.3. So you can say that discriminant validity of these factor is there. Then how to decide for the convergent validity? So for convergent validity, you have to come up. Now, how will you do the convergent validity? You will take the mean of all these correlation. So you add these value and you can take the mean. But in this case, you will see that if you take the mean, it most likely it will be more than 0.7. So the mean of these correlation coefficient, and you will not consider the negative sign, it will be more than 0.7. That means convergent validity is met. Okay. So I will explain the factor loading once again. Yes, definitely. So this was the initial factor loading matrix. So this factor loading, it tells you. Now before that, I'll show you the eigenvalue. I'll explain, Sariful, don't worry. This you can see, this was the variance which I have discussed. This was the inter-factor correlation, this we have discussed. Assumptions check, I have discussed. KMO measure you have seen. Then you go down, this is the eigenvalue. So we discussed that we'll take those factors which eigenvalue is more than 1. So you can see here up till factor 5, the eigenvalue is more than 2. Yes. So if you take 6, then eigenvalue is 0.9. So this Jamovi has decided number of factors based on the eigenvalue, because you have given this command that you want the number of factor extraction based on the eigenvalue. So that's why it has taken out 5 factor. Remember, we have seen that it has taken out 5 factor. And you can see the scree plot also. So scree plot we have discussed. This is the scree plot. And you have to see where is the elbow or inflection point. So this is the inflection point. So you can count the number of factors. So it is 1, 2, 3, 4, and 5. So those many factors you have taken. Again, it is, in this case, it is clear, but many times it is not clear. So it is up to you whether you want to visualize scree plot and then decide, or you want to visualize it based on the eigenvalue. So this is the eigenvalue. So based on eigenvalue, I have decided for the number of factors. And the number of factors is this. So I will again explain the factor loading. So factor loading is, we explain one simple thing here. There is one condition that each item, at least 3 items should load on each factor, and at least 1 item should be of a very strong loading. Strong loading means the value of loading should be more than 0.5. In this case, you will see that this factor 1 it has taken these many items together from E1 to E10. You can see here. And the all has got a very strong loading. How do we define strong loading? If the value of this loading is more than 0.5, we call it as a strong loading. So you can see that all the factors are strongly loaded on, all the items are strongly loaded on this factor. Now coming to factor 2. This is factor 2 and you can see that N1, N2, N3 and then from N5 to N10, it is getting loaded on factor 2. So this is factor 2 and this N4 is not getting loaded anywhere. And you can see the value of uniqueness also, it is 0.841. That means 84% of the variance is not explained by this construct. So you can take a call and you can remove this item of N4. Again, coming down, this is the third factor, which this has identified, JAMOV. So this third factor, you can see the factor loading. All the factor loading in the third factor, this is also more than 0.5. You can see there is one factor which is 0.3. Can you see? Otherwise, and there is one more here also, which has not very strong loading, but it is 0.477. Again, if you focus on this item A10, so if you focus on this A10 item, you will see that it is getting cross-loaded. Now, what do you mean by cross-loaded? That means one item is getting loaded on more than one factor. So if there is a cross-loading, you have to see the values. So both of these two are not having a strong loading. Again, you can take a call to remove this because it is not that strongly getting loaded. At least each item should be strongly getting loaded on some factor. That is also one criteria. But this A10 is not getting loaded very strongly. So that's why you can remove this. Again, with this C3 also, you can say that this is again not very strongly getting loaded. Again, if you come here C4, then you can see this is getting strongly loaded, 0.539 and 0.337. Now, how to decide C4 to consider in item 2 or item 4. So you can see the value. The larger loading you will retain and the smaller loading you will remove that particular item from this factor. So you consider this C4 in 0.539. Remember this because you have to modify this, and now on basis of on this model, you will do the confirmatory factor analysis on the another set of individual, not on the same sample size. So what is the eigenvalue for N4? So N4, let me go and see. So if you go down, you can see here N4 is 0.884. It is 0.884. Sorry. This is the eigenvalue. Okay. So now this was the factor loading. So have you understood all these output? Then I will show you how to report it. Once you are you clear on these concepts? Have you understood this? Okay. Anybody who would like anything to be repeated before I go to the, because I think that breakout room activity is not possible today. So we will start tomorrow's session with the activity. You may revise also once and then we will do the breakout room activity tomorrow. And I'll show you how to report the result. So are you clear on this? This output. Uniqueness, communality, eigenvalue, scree plot, factor loading, discriminant validity, convergent validity, and all those concepts. Okay, yes, I forgot to show you one more thing. No, not the convergent. I have told you that mean or based on the parallel analysis. So what I did, I have shown you that number of factors based on the eigenvalue. If I select this, I told you that many times these days people say that you should use the parallel analysis. So see, if you have used the parallel analysis in the same data set, how many factors it has yielded? It has yielded 7 factors. In the eigenvalue, you took the 5. It has identified 5 factors, but in parallel analysis, it has identified 7 factors. Now the results are in front of you, and then again you can analyze. But again, you can see here, there are few, no, but in this case, you can see that this factor has more, only this one. The last one, you can say there are 2, but again, I'll have to scroll up and see how many factors. 2, 2, 4, no, it is there. 4 factor is there. But again, cross-loading is there. So depending on the method which you choose, whether you are choosing it on the parallel analysis on eigenvalue, the number of factors might differ. You may take a call using either of the method, or you may take a call based on the parallel analysis. It's up to you. Okay. But again, the number of factors, you will have to rename those personality traits. Because if you identify 7 factors, initially the data identified 5 factors: openness, agreeableness, then neuroticism, extraversion, and then consciousness. So originally it has identified 5 factors. But in your data set, maybe if it is identified 7 factors, it is different. So again, you can take a call and you can call expert, or maybe you can decide what to name these factors, or factor 6 and 7, how to rename them, or we have to give some other name to those personality traits. Okay. So we do it like that. It is not a very simple task, but again, if you take a call of taking the eigenvalue, then in that case, this data is very much similar to the what is already proposed. And then you can say that you are going to test this model as a confirmatory factor analysis. Is it okay? Then I'll show you how to report the result. So the reporting of result. So you write that, yes, can anyone read this for me? Yes, Bhavna, I can see your name at the last. So can you read this for us?
Sure, ma'am. An EFA was run on an N-item questionnaire that measured.
N-item means EFA, you can write EFA or PCA, both. Okay. And N-item means like 25. In this case, it will be 25 items. Okay. So yeah. I've removed this with the N like generic one.
Yeah, that measured construct on sample size so-and-so. The suitability of EFA was assessed prior to analysis. Inspection of the correlation matrix showed that all variables had at least one correlation coefficient greater than 0.3. The overall Kaiser-Meyer-Olkin KMO measure was 0.83, with individual KMO measures all greater than 0.7. Classifications of middling to meritorious according to Kaiser 1974. Bartlett's test of sphericity was statistically significant, p-value less than 0.0005, indicating that the data was likely factorizable. EFA/PCA revealed components that had eigenvalues greater than 1 and which explained x1%, x2%, x3%, x4%, and x5% of the total variance, respectively. Visual inspection of the scree plot indicated that so many components should be retained, Cartel 1966. Dash number of components were retained. The n component solution explained dash percentage of the total variance. A dash rotation was employed to aid interpretability. The rotated solution exhibited simple structure, Thurston 1947. The interpretation of the data was consistent with the personality attributes. The questionnaire was designed to measure with strong loadings of so-and-so items on component factor 1, dash on component factor 2, and dash on component factor 3, and dash on component factor 4. Component loadings and communalities of the rotated solution are presented in table 1.
So you can, like communalities, obviously you can write uniqueness, because in the JAMOVI it is the uniqueness, not the communality. And this, I have written this oblique. That means if you are doing a PCA, then you will write component. If you are doing a factor analysis, you will write factor. Otherwise, that's why. And this simple structure, I hope you have understood. This simple structure means that each item will have a strong loading on at least one factor, and each factor will have at least 3 item getting loaded. Okay. So while reporting, do we have to add the references? No, it's not needed. You can, I just saw this. This was there in one standard textbook. This was just to remember that cattle, given the concept of this eigenvalue and the scree plot, you can remove that. No need. Okay. So data set has been shared with you people, and please practice that on the stars data. And then maybe we will see tomorrow in the breakout room activity how to do that. And but you have to finalize also. Like in this case, I will also finalize today which item I have removed, and those item I will enter it in the CFA. That is the confirmatory factor analysis. Is it clear? So we are sharing 2 articles also with you regarding that general health questionnaire. In one, I think it was done in the China, and another was done in another region. I forgot. So you may read those articles, and you may have a feel how this factorization, it may have a geographical implications. Okay. So with that, we are ending today's session. Good day to all of you, and thank you. So see you all again tomorrow at 2 p.m.